Okay, section 2.4 is linear inequalities and problem solving. Remember, problem solving is our book's way of saying word problems. So we have three objectives in this section. The first is to look at how to use interval notation. The second is solving linear inequalities. Solve had to be. And the final one is word problems or problem solving with inequalities. So we need to talk about what linear inequalities in one variable are. So it's simple enough. This is an inequality with only one variable, just like our equations. No exponents on that variable, and it can be written in the following form. Ax plus b is less than c, and the only requirement being that a is non-zero. So this should look pretty similar to what our linear equation definition looked like. We're just swapping out an inequality symbol for an equals, reverse that, an equal symbol for inequality. And this isn't the only inequality symbol. We also have less than or equal to, greater than or equal to, in addition to that less than. So you can replace this symbol with any of these four, and it's linear. Again, just throwing some examples out here for us to look at. Remember, it can be written in this form, not necessarily in that form to start. It's our job to be able to rewrite it like this, which is the same as what we did with the equations. So we'll come back to the inequalities when we're solving them in a little bit here. But when we're talking about interval notation, we have two forms of intervals where our endpoints are excluded and our endpoints are included. So when we say excluded, that means that the endpoint, the end of that interval, is not in the actual values that we check, and these are always using parentheses. So parenthesis a to b says everything in between a and b, but not including a and b. And then when we want to include our endpoints, we use brackets. Bracket a to b, close bracket. And so this says everything in between a and b, as well as a and b themselves. And you can combine these, so we can have, I'll write it down here, we can also have parentheses a to b with a bracket on b, where we include only b. And we could also have a bracket on a and a parentheses on b, where we include a but not include b. So the next example here is this chart. Again, you can think of this as the chart that we saw a few lectures ago. This is a reference for you. So we have set notation on the left. We have what the graph would look like if you were graphing that inequality inside the set. And then we have what the interval notation is. And you can see there's a bunch of different versions. We have infinite intervals, or intervals that have either negative infinity or positive infinity. We have excluded endpoints, included endpoints. We have all the different versions you can see and what those graphs look like. So this is a good reference point for you as you're working through the practice and working through the homework. To take a look back, if your interval looks like one of these, you know what your graph is going to look like. Now, one thing you will notice here that's important, we're going to write down at the bottom, is how we notate intervals that have infinity. So infinity, not a number. Can't stress that enough. Infinity is not a number. And that means that it can't ever be included. So you'll see here, negative infinity to a to infinity, negative infinity to a to infinity. Every side that has an infinity, even down here, has parentheses. So parentheses are always used with infinities. no matter what. Both versions. So let's take a look at some examples here. My formatting went weird. This is less than or equal to. Yours should look correct. So we're going to graph the following sets and then write in an interval notation. So this notation that we have here is set notation, or sometimes called set builder notation. So for A, we want to write this inequality as an interval. So it says greater than or equal to -5. Since we can be equal to -5, we're going to have a bracket on it. And then anything bigger, and that goes forever all the way up to infinity, and parentheses on that infinity. And then if we're going to graph this, you'll want a straight edge, but you can just use a book or a credit card or an ID card. If you have a ruler, that works too. So we need to get to -5, 2, 3, 4, 5 here. And then if you look back at that chart, what we do is we take the bracket, put it on the -5, point it in the direction, and then draw an arrow to indicate that that continues on forever. So notice we don't need, you probably have done number lines where you put 0 perfectly in the middle and you space it out and you have 3 to the right, 3 to the left. You don't need that when you're doing inequality graphs. You want to get the pertinent information. In that case, in our case, it's -5 and it needs a bracket. So I don't need to worry about any of the positive values. The arrow tells your reader or whoever's looking at your work that that continues on forever. So if we look at part B now, this is -2 less than or equal to x less than 6. So that means that -2 all the way up to 6 is going to get included. -2 is in the interval and 6 is not in the interval. So we have a bracket on the -2 and a parentheses on the 6. And another number line here. So now we need to get from -2 all the way up to 6. So I'm going to put my 0 a little bit this way, so I can get out to -2 with no problems. 2, 3, 4, 5, and up to 6. Problems. So again, we come to the -2, we put our bracket, and at 6 we put a parenthesis, and then we just darken up that number line, like so. So if you have different colored pens like I do, that makes it really easy, but don't worry about that and use your pencil, it's fine. Just darken it up so you know. And then our last set is all x's, such that x is less than 12.6. So we know that x needs to be less than 12.6, so that's going to be the upper bound. It is not included because it's simply less than. And whenever it's anything less, we go all the way to -infinity. So now I need to get all the way to 12.6, so I'm going to put my 0 way over here. 4, 6, 8, 10, 12, counting by 2's. So I need to put a parenthesis at 12.6 is a little more than half, would be about here. I'll put a parenthesis here. And give my arrow all the way across. So whenever you have fractions or decimals, you don't need to put fractions and decimals into your number line. Add the value that you are putting in this case 12.6, and make a little note underneath and add it into it. So whoever's looking at it knows, oh, that's supposed to be 12.6. You don't need to be perfect. You just need to be roughly where it should be. So there's a practice problem there for you to try doing the same thing. We're going to continue on here into solving inequalities. So we're solving the following inequality, and then we're going to write our answer in an interval, set notation, and then graph it. So the nice thing is, when you're solving inequalities, you treat it just like an equation. So we're going to basically solve this for x, and we're just going to treat the inequality like an equal sign. So we're going to -5 both sides. 3x is less than 20. Divided by 3, -20. x is less than negative 20 over 3. So as an interval, it's less than negative 20, so this looks a lot like part C up here did, less than 12.6. So that means we're going to start at negative infinity and go all the way up to negative 20 over 3. As a set, it's the curly brace, and we do x, one vertical bar, and that's read as such that. So this is read as all x such that x is less than negative 20 over 3, and then another curly brace. So we have interval notation, set notation, or set builder notation, and now we need to graph it. So I need negative 20. I don't need anything else. So I'm going to put my 0 all the way over here. So negative 20 over 3 is negative 6 2/3. So I need to get all the way to negative 7. So I'm going to do 1, 2, 3, 4, 5, 6, 7. And negative 2, negative 4, negative 6. So negative 6 2/3 is about here. So we're going to add that mark in. It's a parenthesis. I'm going to write negative 20 over 3. So whoever's looking at it knows that that's what that is. And we do our arrow. Off to infinity. Okay, so the next 3 examples are the same process, just to get some different ideas of how you could see an inequality. So on this next one, just going to divide by 3, divide by 3. So we have y is greater than or equal to 7 over 9 divided by 3 is 7 over 27. Or we have y greater than or equal to 7 over 27. So as an interval, we start at 7 over 27, and we just keep getting bigger all the way to infinity. Infinity always has a parenthesis. 7 over 27 has a bracket. As a set, we are all y such that y is greater than or equal to 7 over 27. And then graphing this, we're all positives. We need to start at 7 over 27, so I can put the 0 way over here. Now, if you think of 28, half of 28 is 14, and 7 is half of that. And I know that this is 27, I didn't just lose my mind. But that means that this is less than half, this is less than a quarter of 27. So I don't need very many values here. So I'm going to do 1 and 2. And I use 28 because 7 goes into 28 easier. So I know that this should be about a quarter-ish right here. Again, we're not looking to be perfect, because I just added in and write 7 over 27. It needs a bracket. And then our arrow. So we have our interval, we have our set, and we have our graph. Okay, so the next one now, solve this inequality. So the first thing we're going to do is distribute the negative. Negative x plus 3 plus 2 is less than or equal to. I'm going to distribute this 3. So we have 6x minus 15 plus x. Now, if you remember our system, our little setup for solving equations, the next thing is to collect like terms. So we have negative x plus 5 is less than or equal to 7x minus 15. Then I'm going to move minus 5, minus 5, minus 7x, minus 7x. These go away, these go away. We have negative 8x is less than or equal to negative 20. Now here is where the only rule change happens for when you solve inequalities versus equations. When we divide by a negative with an inequality, we have to flip this inequality symbol. So we divide a less than or equal to by a negative, it becomes a greater than or equal to. And this is positive 20 and 8 are both divisible by 4. This will be 5 over 2. So that's the only difference here, is when you divide by a negative, you need to flip your inequality. So now we have our inequality as an interval. This starts at 5/2. It gets a bracket, and it keeps going all the way up to infinity. And we need a number line and a set. So let's do the set here. This is all x, such that x is greater than or equal to 5/2. And here we have a 0. 5/2 is 2.5. So we need 1, 2, 3. So 2.5 right dead set in the middle. Put a bracket there. And an arrow continuing on. Okay, and then our last one here, distribute the 3. 3x minus 12 is greater than 6. Add 12 over. 3x is greater than 18. Divide by 3. We have x is greater than 6. As an interval, this is parentheses 6 to infinity. As a set, this is the set of x, all x, such that x is greater than 6. And our number line here, start at 0, 2, 4, 6, 8. We are starting at 6. We need a parentheses because that's what we have on the interval. And then that continues on forever. So good number of examples here. And there are some practice problems that you'll work on. Now the last little bit is just some definitions and some steps. These steps are going to look very familiar. So all the things that we used to solve these inequalities comes down to these properties of inequalities. And the first one is the addition property. It says if a is less than b, then a plus c is less than b plus c, just like with the equation. Multiplication property, if a is less than b, then AC is less than BC as long as C is not 0, just like with the equation. And as I've written here in this little note, this is true for all 4 inequality types: less than or equal to, greater than or equal to. So our steps for solving a linear, I wrote inequality in one variable. So the first thing is to clear all fractions and decimals by multiplying by an appropriate number. Step 2 is to use the distributive property and collect like terms. Third is use our properties of inequalities. To isolate the variable. And the fourth is to write our solution in our appropriate format. So if we want interval, interval. If we want a set, if we want a graph, a graph. Or as we did in the examples, all 3. Appropriate form. So no different from our equation solving. And this is the end of 2.4.